A quadratic function is in general form when it's in the form f of x equals ax squared plus bx plus c. The vertex can be found using the formula here. Note x must be negative b over 2a. Once you figure out what x equals negative b over 2a is, to find the y value, we will then just plug in whatever number that is into the f function. Notice f evaluated at negative b over 2a gives us the y value. Like in the previous example, when a is positive, that is when a is greater than 0, the parabola opens up. If a is negative, the parabola will open down. For example, let's graph this quadratic function. Notice that it's in the general form. When it's in general form, finding the vertex, we use the formula x equals negative b over 2a. We have negative 6 divided by 2 times 3. 6 divided by 6 is 1. To find the y-coordinate, we plug 1 into the function. So f evaluated at 1. 3 times 1 squared minus 6 times 1 plus 4. This will give us 1. It's just coincidental that they are the same value. We have the vertex at 1, 1. To find the x-intercepts, we make y 0. 0 equals 3x squared minus 6x plus 4. Factoring is not going to work here, so we may need to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. This will give us 6 plus or minus the square root of negative 12 over 6. Since we have a negative under the radical, that means that that number is actually imaginary, which means we have no x-intercepts. There are none. And if you are paying attention to the original function and the vertex, maybe you notice that without even finding the x-intercepts. Notice that the vertex is 1, 1. And since a is positive, we know this graph opens up. We have a smiley face for the parabola, which means it never crosses the x-axis, which means we have no x-intercepts. But it never hurts to use the algebra to confirm that. To find the y-intercept, we will make x 0. 3 times 0 squared minus 6 times 0 plus 4. This gives us 4. So our y-intercept is at 4. Remember that there is a vertical line that goes through the vertex called the axis of symmetry. We can use that line to get an additional point. Since we don't have x-intercepts, we may need an extra point. We know that we have the y-intercept at 0, 4. Using symmetry, we know there must be a point over here at 2, 4. And using those 3 points, we can get a rough sketch of what the quadratic will look like. This time we have a relative min. The min this time is 1, that y value. The domain is negative to positive infinity. The range starts at the lowest y value and goes up forever. The axis of symmetry, as we said earlier, is x equals 1.